Hello, assalamu alaikum. This is a data set of a um, student data set actually, right? So we collected this data from this paper, right? This paper published in the Data in Brief, right? So uh, the title of this paper is Measuring E-Learning System Success, right? The case is from Morocco, right? Uh, the students are from Higher Educational Institute. Okay, so in the last video, actually, we talked about measurement model and the structural model, how we can uh, measure the measurement model and structural model, how we can evaluate. By the way, that was the separate video, but in this video actually I will try to cover how we can do it in together, how we can evaluate the measurement model and structural model together, right? So this video maybe is quite long video. However, we will use this conceptual model. So we take this model from this paper. This paper is a open access, right? Open access paper, and the data set is also open access, right? So based on this model and based on the provided data, we will investigate the e-learning system success, right? Based on this predictor variable. Okay, so how we can do it? So please see here. This is the research question. So based on this research question, see here, this all are the Likert scale research question, right? Just 1 minute. Okay, so please see here, they used this the Likert scale research, Likert scale response, right? Here you will find some variables, I mean constructs. So one is the system quality, another is the instructor quality, that was the perceived usefulness, then how can I say, learners computer anxiety, right? And there are some others, for example, social influence, e-learning system use, e-learning satisfaction, and finally e-learning system success. So each construct have several measurement item, right? These are the measurement item. This all are the measurement item. Okay, these all are the measurement items. So based on this measurement item, the researchers actually collect the data using the Likert scale questionnaire, and finally this is the final data set. Okay, okay. So what is our model actually? This is our model. So using the smart PLS, we need to draw this model first. Okay. Okay, here is the now we need to import the data, right? So this is the data set, e-learning system success data set. So just open and click import, right? So you see here all the demographics variables or some demographic statistics, right? Descriptive statistics are in here, right? So in this stage actually we don't need it. Okay, so second step is to create a model. So click here, right? The practice 2. What types of model? PLS 2 model, PLS SEM model, practice 2, right? Just save. Here you have the space to create a model. So what is the model? How? For example, social influence, system quality, instructor quality, and learner computer anxiety, right? So 1, 2, 3, 4 is the predictor variables, SI. So how we can do it? SI, right? Social influence is the 4, have the 4 items, social influence. Okay, so just click OK and make it here. Okay, social influence. Second one, system quality, SQ, maybe SQ, system quality. What is this? Yes, SQ, system quality, 3 items. Okay, is the system quality. uh just make it okay. And third one is instructor quality, right? Quality, uh Okay, instructor quality IQ. So IQ 5 items actually. Okay, just do it. Just do it. Okay, this is the instructor quality, and finally learner computer anxiety. Learner computer anxiety. This is the 3 items. Okay, it has the 3 item. Okay, so I'm just making it here, right? So this is for independent predictor. So there are some mediating factor, e-learning system use. So e-learning system use, where is it? Uh, e-learning system use, there are 6 items. E-learning system use, right? What is this? E-learning system use. Uh, e-learning satisfaction, ES, system success. E-learning systems as 1, 2, 3, 4, 5, 6. E-learning system success. This is the dependent variable, right? So is the dependent variable e-learning system success. Here we need to identify e-learning system use, perceived usefulness. Okay, perceived usefulness, PU, uh, perceived usefulness. I'm just making it a perceived use. E-learning, say e-learning satisfaction, e-learning satisfaction, e-learning satisfaction. Here, e-learning satisfaction the 6. Okay, this one is the e-learning satisfaction, right? Okay, uh, just make it in here, put it in here, e-learning satisfaction. So e-learning system use, it means mm, e-learning system, for example this one, e-learning system, right? This 6 one, e-learning satisfaction, sorry, e-learning system use, this one, e-learning system use, we have the 6 item, right? So here, why it's alpha, e-learning system use, rename, it should be here, e-learning system use, ELU. Okay, so this is the model. Hmm, right? Okay, in this way we can draw this model. We can draw it in here. Okay, this one is quite good. Okay, it's quite good. So need to create the relationship, social influence to e-learning system you use. So here one, system quality have 3 indicators, 1, 2, 3, right? So uh, system quality 1, 2, third one is e-learning satisfaction, e-learning satisfaction, this one. Okay, so this one 3, 1, 2, 3, instructor quality, e-learning system use, perceived usefulness, and e-learning satisfaction. Okay, so this one is learner's complexity is one variable. Yeah, this is right. Okay, so I'm just making it in here, and to show it more systematically, I'm just making it in here, right? So in this way we can easily understand. And finally we have to make it this one, right? And this one. Okay, and now this one, 1, 2, 3. Okay, so this is the model we have draw. Okay, so this is the full model actually we have draw, right? So to make it more furnished, like here, okay, like here, okay, this one, uh, I'm making it more furnished in this way, right? Sorry, in this way. Okay, and this is the final variable. uh, can make it these two variable here, right? Here, and these two variables are in here. Okay, so to make it a measurement model and the structural model, first we need to calculate the PLS algorithm, SEM algorithm. Okay, just start calculation. So this is the PLS SEM algorithm, right? So here we can identify the model, right? Where is the model fit? So it's the model fit. Oh, excellent, 0.05. So if you see the previous video, so if it's less than if it's less than 0.08 or 0.09, it's excellent, right? So it's excellent model fit. On the other hand, we can go to the construct reliability. Please see here, convex alpha value, composite reliability values, right? And the AVA values all satisfied the uh, threshold value. Actually, it's all are greater than 0.07, right? Greater than zero point 0.7. Okay, it's also is greater than 0.07, right? And here is also greater than 50%. I mean 0.5, 50%, right? So construct reliability and validity confirmed, right? So second, we need to confirm the discriminant validity. Please see here, all the discriminant validities are confirmed. Next, we need to see the Fornell-Leclerc criteria. Please see here, Fornell-Leclerc criteria. I think all the criteria is already filled out, because here see that this value is greater than all other value, right? This value is greater than all the values, and these values, please see here, these values is greater than all these values, right? So similarly, similar to the all columns, right? Eventually, if you think about horizontally, it's same. So, please see here, see here, this value and is greater than. So I'm just showing you the example purpose. So discriminant validity also confirmed, right? Okay, so our first approach was to investigate the outer loading, right? Outer loading. Okay, so if we click here outer loading, all the values are greater than 0.6, right? Though we consider it should be greater than 0.7, but greater than zero point 0.6 is always right? So on the other hand, we will check the R square value. Yes, excellent, 68%, 78%, 47%, and 50%. That's great. Okay, so f square value, which contains the which means indicating the effect size. So these two variables, perceived usefulness and service quality, may be this the low effect. On the other hand, there are some moderating effect, right? Because we for moderating effect we need to the value up to 0.15, and some of the value have the large effect to the dependent variable. Okay, just calculating it, I calculated this one, right? And for future purpose, I'm just exporting it in the Excel. Okay, Excel, I just rename it algorithm, algo. Okay, algorithm, algo. For future purpose, I mean the for future reporting, I'm just saving this one, right? Just export this, or export all the results, right? Okay, just delete it, and it's time to investigate the structural model, right? So for investigating the structural model, just click the bootstrapping. So if you click the bootstrapping, it will take some times, right? uh, okay, so it's the hypothesis testing actually. So if we click here path coefficient, all the p values are significant except this one and this one, right? This didn't significant. Actually it's an insignificant value. Otherwise all the hypotheses, these all are the hypotheses, all the hypotheses are significant, right? So beta values have the majority of the beta values have the positive relationship, except this one and this one. So these two variables has the negative relationship, and these two variables have the negative relationship. Otherwise all the variables are in and positive, have the positive relationship. Okay, so this is the path coefficient, I mean the hypothesis testing. Okay, so maybe in some cases you need to investigate the total indirect effect. So if you click here the indirect effect, so you can see here the indirect relationship between these two variables are insignificant, this one and this one, right? Otherwise these two variables, okay, this one it's the insignificant result, and these two variables has the insignificant relationship, right? Otherwise all the variables have the significant relationship, and only 1, 2 and 3 variables have the negative relationship, and otherwise all the variables have the positive relationship. Please see here, except this one and except this one, otherwise all the variables are in positive relationship, right? Okay, so we investigated the hypothesis testing, just direct and indirect relationship. Here you will find the total relationship, I mean the total relationship, it means the direct and indirect relationship, you will find this one, right? Okay, we will also export this one, for example this one, rename bootstrap. Okay, bo, okay, I'm just renaming it bootstrap, right? Okay, so just delete it, go back to the model. In some cases the sorry, actually we need to calculate the blindfolding, right, for predictive relevance. This is the blindfolding. Okay, just click here the blindfolding, right? Okay, so here you will see all the values, q square values is greater than majority of the q square value is greater than uh, the I mean the greater than 0, right? And no value is less than uh, 0, I mean no negative value. It means the predictive relevancy is quite good, right? Okay, so in this way we can also calculate the predictive relevance. Okay, so I also export this one for the future. So blindfold, I'm just renaming blind, li and blind. Okay, so in this way. Okay, I'm just also cutting this one, but sometimes there is a problem actually. Here you will see 4 independent variable, 3 measurement, sorry, 3 mediating variable and 1 dependent variable, right? So in many cases actually we need to investigate which predictor is most important for the dependent variable, right? So in that case we can use the analysis of IPMA, important performance map analysis, right? So just click here, important performance map analysis, and select the target variables. Which one is the target variable? Our target variable is ELSS. Okay, so ELSS is our target variable, and all others are the independent variables. Just start calculating, right? Okay, so here you will find the importance performance map of construct, right? Or important performance of map of the indicator. So we will investigate this one, the construct, right? So this is the uh, uh, how can I say, the graphical presentation. From here we can see the importance is too high. This one, perceived usefulness, maybe perceived usefulness importance is too high, right? But its performance is quite low. Please see here, importance is around 60%, right? But performance level is around 40%, right? So on the other hand, please see this one, the ELS. I'm not sure which one. ELS, it means ELS, e-learning satisfaction. Okay, so its performance is also sorry, its importance is also high. E-learning satisfaction is also high, right? But it has very low performance, I mean around 35%, right? In that case, organization should take the initiative to enhance the performance of these two variables, like the perceived usefulness and the uh, e-learning satisfaction, because its importance is too high for what is the research question, or what is the, yeah, let's see here, measuring e-learning system success, right? So for e-learning system success, the e-learning satisfaction, right, here please see here, uh, e-learning satisfaction and the perceived usefulness, its importance is too high, but its performance is quite low in the educational institute, I mean higher educational institute, right, higher educational institute. So we can take a decision, higher educational institute should take some initiative to enhance the performance of e-learning satisfaction and perceived usefulness of the student, right? So using the important performance map analysis, we can conclude this, and uh, which factors are more important and which factors are low important, in which factor we should focus or organization should focus for future uh, enhanced decision making. So using the IPMA, I mean important performance map analysis, we can take this decision. Okay, so it's all about the uh, result analysis, actually how we can uh, create a model, how we can test the measurement model, how we can test the structural model, and how the predictive relevance is, what are the level of predictive relevance, right? And finally, which factors are more important for the organization, and where we should focus for or to develop, or which variable we should develop, we should focus on which variable for the future development of the organization, right? So using the IPMA, we can do it. So it's all about the um, PLS SEM, right? So I hope this video will help you to take a, or to get a whole idea how we can create a model, create a project, then how to import the data, and how to create a model, how to create the relationship, and then how to investigate the measurement model, how to investigate the structural model, and finally how we can investigate the predictive relevance, and finally how we can investigate the important performance map analysis. It's all about the structural equation modeling using the I mean the partial least square based structural equation modeling, right? So this video will help you a full view, full idea how you can perform this PLS based SEM analysis using the structural PLS SEM, sorry, smart PLS 4 software, right? So in the next video, I'll try my best to present how to report, right? So how to report this, that is why I have already sorry, just export, I'm just right here the IPMA, right? Okay, uh, IPMA. Okay, so I'm just exporting, or I exported all the results, and in the next video I will show how to report the result in a perfect way, scientific way, systematically in your research paper or in your thesis, right? So up to the next video. Okay, Allah Hafiz, bye bye.